Okay, my name is Penny Johns. I'm from the University of Bristol, and the programme that we've had funded under this call is called Quantum, which is going to be quantifying a broad range of stressors impacting on UK rivers that are derived from livestock farming. So this is University of Bristol, Bangor, Bath. You don't have to plug in with B to be in our team. We've also got Exeter and Lancaster, and then we've got our project partners along the bottom: DEFRA, Natural Resources Wales, Natural England, Uckware, Wessex Water, Welsh Water, and Harper Adams Agricultural University. So in terms of the team, I'm the PI, and I'm going to also be leading our work package 4, which I'll explain to you in a little while. Dave Chadwick is leading our work package 2. His expertise is on soil nutrient cycling and livestock farming systems, and particularly field scale experimental approaches. Barbara is also involved in Dan's project that you've just heard about. So she's a link person there directly, and she's our ecotoxin chemistry lead, particularly with expertise on looking for pharmaceuticals in the environment. Richard Evershed will lead work package 1, and he's our local expert from the School of Chemistry in Bristol on isotope and molecular scale organic geochemistry. Then we have Andy Binley from Lancaster, who's leading work package 5, and is also bringing his expertise in field hydrology and geophysical exploration to make sure our experiments are actually measuring what we think they're going to be measuring and not a completely different flow pathway. David Jones can't be with us at the moment because he's in Tenerife, but he's our pathogens lead. We will do our best to answer any questions you might have on the pathogens element of our work, but it's David who's leading that. Charles Tyler is our work package 3 lead, and he's our ecotoxicology lead in the programme across all of our work packages. And then we have Ian Bull, who's our analytical lead, and he's got particular expertise in using what we call fecal biomarkers to identify the origins of organic matter in soils and freshwaters. We're planning to appoint around 5 postdocs, 4 technicians, and then we have our 7 project partners listed there. So in terms of the programme, we're focusing very much on livestock farming, which is a key driver of changing water quality in UK waters. Cattle and sheep farming is concentrated in the wetter north and west of the UK. It's located largely on about 10 million hectares of grassland, which comprises over 50% of all UK agricultural land. For some reason, my mouse is going upside down at the moment. Let's try using the arrow. There are around about 10 million cattle and 33 million sheep in the UK in 2020, and these are excreting 4 times as much nitrogen and 3 times as much phosphorus as people in UK catchments. And of course, their wastes, their excreta, are not going through a sewage works before they're discharging into watercourses. Some of them avoided directly, many of them avoided in the riverbank area. That's not working either. Let's try this. Okay. 80% of the estrogen in the UK environment derives from livestock, and cattle excrete an order of magnitude more estrogen than humans. And of course, it's not the only endocrine disrupting chemical we're concerned about, but it's definitely one of the ones that's a target. Livestock-derived pathogens, veterinary pharmaceuticals, and other ecotoxins, their processing, critical concentrations, their ensemble impacts in river ecosystems actually remain to be established. We know very, very little about them, and we really don't know how they interact then with the livestock-derived organic nutrient loading. So, and the final focus for the project is the role of environmental character and function in transforming these contaminant mixes and then realising their actual impact on the riverine biota. That's also largely unknown, and that creates huge uncertainty in terms of the efficacy of both current mitigation and management strategies and their likely efficacy under future climate change. So how well are the current measures we have working, and how well might they work if we start to disrupt the hydrological flow pathways and other conditions within the catchments? So the focus is very much on livestock farming, and I really wanted to work on poultry and pigs as well, but my team persuaded me that was way beyond the scope of the budget we had available. So we're focusing on cattle and also on sheep. But we're not just focusing on them in terms of quantities of those the livestock in the environment. What we're really interested in is the practices on farms, the pathways that link those sources to streams, and then the ultimate impacts. So if we have directly watering cattle in the stream, that's going to have a different impact than if those cattle are held in store. We have dirty yards, we have slurry lagoons, we also have our manure wastes, and then we have the application as in the form of muck or in the form of slurry. We have poaching within the landscape. So the question is, how do those processes and the ways in which we're managing livestock within the environment impact differently in terms of the chemistries and the total loading of these stressors in the freshwater environment? So in terms of the programme, it's structured around 5 work packages. So we start with work package 1, defining the chemical and microbial character of different forms of livestock excreta. Then we have work package 2, which is going to investigate how manure management and environment and in-stream processing transform the contaminant pool to which the biota are then exposed. In parallel, in the same experiments, we have work packages 3 on ecotoxicology and 4 on the nutrient enrichment impacts of livestock excreta on freshwater biota. And then finally, in work package 5, we'll be developing pan-UK advice on livestock as a driver of changing quality in UK rivers. So in terms of how that fits to the themes, theme 1 is focused on livestock farming, is going to be delivered through work packages 1 and 2. Gosh, it's going backwards again. Sorry about this. Theme 2 is investigating the impacts from different types of livestock farming in UK river ecosystems. That's going to come from work packages 3 and 4. And then theme 3 for the main programme, again, focused on livestock farming alone, is going to be delivering on theme 3. And just to back up some of the things that we were asked to do when we were asked to bid for this programme, we are very much basing the approaches that we take on a suite of novel approaches for characterising dissolved organic matter, maybe over 100,000 different compounds within it. We're going to be using targeted and non-targeted methods to get to grips with that material. We're going to be using bulk and compound-specific stable isotope probing developed in our prior UK RI funding research, and a suite of novel approaches to actually collecting samples. So we have our traditional water samplers, our SONs. So for programs which are using high resolution sensor data streams, we'll be able to contribute more streams to you if you'd find them useful. But we'll also be using things like this polo shaped thing. It is a POSIS disc, and you can sandwich an extraction membrane of your choice to target a particular group of chemicals. You put it into a crate, you put that into the stream, and that allows you over the course of maybe a month to trap the environmental exposure for the organisms that's moving through the ecosystem. And then, of course, we have everything from traditional field-based laboratories through to our own nutrient chemistry laboratories, through to radioisotope and stable isotope facilities for the analysis of samples, both at Bristol and also in Bath. Sorry, it's gone backwards again. So just to take you through the work packages, and I won't go through these in a lot of detail because you will have access to these slides. We're perfectly happy to share these with the other groups and anyone on the call. We have access to 3 university farms. So there's Henvice Farm Research Centre, Bangor University owned, which has a focus on sheep. We have access to the John Oldacre Dairy Research Centre, the University of Bristol and our vet school. And then on top of that, we have with our project partners, Harper Adams Agricultural University, access to a major Innovate UK and DEFRA funded slurry management programme, where they're looking at how they can manage slurries in different ways to reduce their phosphorus loading as they go out into the environment. And the very interesting thing for us is whether that management does anything to the exposure to all of these other ecotoxins and organic matter nutrient compounds that are present in that slurry. Does it make any difference? What's the exposure regime once it arrives on the field? So the questions we're answering in work package 1 are: to what is the chemical and pathogen content of these excreta of differing type, and how does that composition vary according to the type of system and management? And that's going to define the sources that are then going to be going into the rest of our work packages. In work package 2, we are going to be focusing on 4 research questions. How does the composition of livestock-derived organic matter, LDOM, delivered to streams transform due to in-stream processing? How does the stream organic matter pool composition transform in response to hydrology and climate, which is going to allow us to build into our models the likely future behaviours under climate change scenarios? How does it transform according to in-field management practices? And what are the exposure rates for these targets under contrasting flow and management for organisms from epilithon? So these are microbial and algal communities, through to the bryophytes, or plants that will be growing in those water bodies, through to the invertebrates and also to the fish. So we're trying to cover a broad spectrum of biotic groups, and we're looking forward to potentially linking up with the microbial focus on Dan's project. So in terms of how that will actually work, we're looking to set up 2 experimental catchments, one in North Wales, possibly in the Hiraethlon, one in the Chew, or possibly just over the hill, because that would then allow us to work in the exact same catchment as one of the foci for Dan's project. We'll have a non-agricultural headwater, we'll have an experimental field, and we will have an experimental reach. And what we're going to be doing is in B, as you can see here, we're going to have samplers upstream from a trickle bar that will be introducing urine at a slow dose rate into the stream, and then we'll be sampling it at sites 3, 4 and 5 to see how that urine transforms as it moves through the stream ecosystem over time. And then in the field experiment, we're then going to be setting up a series of strip grazing or slurry amendments at differing distances from the stream. We'll be collecting samples in through flow and overland flow and within the stream and comparing the chemistries that we see there. And then at sites X, Y and Z, we're then going to be introducing our work package 3 and 4 biomonitoring experiments. In terms of work package 3 then, this is led by Charles Tyler, and what we're going to be doing is asking what the toxicities of key compounds are in the livestock excreta that we've identified in work package 1 to the freshwater biota, looking at invertebrates and fish and probably cyanobacteria as well. We're also going to be looking at the bioaccumulation rates and effects in invertebrates and fish, and doing this under controlled laboratory conditions so we can compare with standard ecotoxicological approaches. But we're also then going to, for the first time, take this out in the field, and we're going to be doing these ecotoxicology experiments under ambient exposure rates in those field experiments. So that's going to be really exciting to see what they're actually exposed to in the real environment rather than the artificial dose rates we can simulate in the laboratory. Then work package 4, we're going to be moving on and saying, well, what's the nutrient enrichment effect of these materials? So how does nutrient uptake vary between the different livestock excreta and chemistries? How does it bioavailability vary according to environmental character and function? And how is the uptake modified by the matrices and interacting stresses that we see in livestock excreta? And we're using a really nifty, very new approach we developed at the end of a large grant program that finished 2 years ago in order to be able to facilitate that investigation. And then finally, in work package 5, we're going to be developing pan-UK understanding and advice on the importance of livestock as a driver of changing quality in UK rivers. So what we want to say is, are there generic livestock impacts on UK rivers that are linked to livestock type and environments? How might those impacts change in response to a changing hydrological cycle, potentially under climate change? And then can we produce transferable evidence to improve policy and management? And this is very much where we're going to be working very closely with our stakeholders to specify and develop the scenarios that we're going to be running through the model. So we have 2 phases. I'm going to come back to the first one in a minute, the sampling and analysis, but we're also going to be building the HYPE model. And this is actually very well suited to the types of data that we're going to be producing from our field and laboratory experiments. So we're going to build that for cattle versus sheep farming in different environments under ambient and climatically altered conditions. We're going to validate the data using the data we're going to collect in tier 2, which I'll show you in a moment, and also with published and project partner data, and if there are data available from other of the programs running under the Freshwater program. Scenario testing in consultation with our regulatory, industry and academic partners in order to generate this pan-UK understanding. In terms of how we'll do that sampling then, we have our 2 main sites here in triangles. So this is our tier 1 sites, but we also have our domain site we've previously investigated on, which represents the type of grazing you would see in upland environments on rough grazing. What we're going to do then is we're going to go out to up to 15 further sites for each one of those colour categories, and we're going to collect samples there, characterise their DOM chemistry, and use those to explore whether we actually, if we're in an upland sheep grazing environment, we always get the same range of chemistries and then can therefore expect the same range of biological outcomes and impacts on those freshwater ecosystems. We've done this before in the domain programme and it worked absolutely brilliantly, far cleaner relationships than we were expecting. We really do, although the environment is complex, there are also clusters of behaviour that cluster together, and that really helps if we're trying to then feed our understanding into perhaps the development of the sort of models we heard earlier. So just some highlights to finish off. Work package 1, combining our novel methods for characterising these multiple contaminant profiles in rivers to diagnose the nutrient, pathogen and ecotoxin mixtures exported to rivers from different types of livestock farming, and that's building on a whole range of these prior UKRI funding initiatives. We also have in work package 2 exploring how livestock production methods in different environments produce different multiple chemical and microbial exposure regimes in stream, taking laboratory-based ecotoxicology approaches out into the field for the first time to really understand what the organism is actually seeing under field ambient conditions. And if you want to know more about this, I'm glad to say that Charles has just joined the call, so you can direct your questions to him. Work package 4, using these novel stream isotope dosing approaches to determine these compound environment and species-specific responses to this livestock-derived organic matter. Oh, it's gone the wrong way again, sorry. Something wrong with my mouse. Let's see if I can, oh, if I click, that works. Okay, and then finally, in work package 5, embedding our Tier 1 experiments within the National Tier 2 programme to generate this pan-UK understanding of impacts of different livestock production systems as drivers of changing quality in UK rivers. And I would just say that we don't know whether we're going to be able to go to Northern Ireland, but we will definitely get around Scotland and Wales as well as England in order to expand this to full national scale. The issue with going to Northern Ireland is getting the samples back in time before they degrade, so in order to be able to do the analyses in our laboratories, but we will look into that. Thank you.